Ladies and gentlemen, given that dy dx is equal to sine x plus 2y, where y naught or y of 0 is equal to 1, and step size h is equal to 0.02, find y of 0.08 by Euler's method. So now we are going to use Euler's method to find the solution of this ordinary differential equation. And it is from there that we are able to find that value, which is x is equal to 0.08. We want to find the value of y at that value of x. So using Euler's method, we know yn is equal to yn minus 1 plus h f of xn minus 1 yn minus 1, where also xn is equal to n minus 1 plus h. And we are provided that x naught is 0 and y naught is equal to 1. So what is the solution that we need? We need first of all look at y1, because we want to look for the solution of the function at x is equal to 0.08. Since the step size is 0.02 and we are beginning from 0.00, then we shall just keep on adding 0.02. So x1 shall be 0.02, then x2 will be 0.04, x3 will be 0.06 up to 0.08. So here, when we substitute the values for x naught and y naught in the function f of xy, we shall have sine of 0 plus 2 times 1, and that is going to give us 2. Therefore, y1, which is going to be y naught is 1, plus h, which is 0.02, times 2, which is the f of x naught, y naught that we have obtained here. And therefore, y of x1 is going to be 1.04. What next? We have, of course, obtained that value, which is y of x1. And therefore, since x1 is 0.02, that means we have obtained y of 0.02, which is 1.04. But we are looking for y of 0.08. So that means we need to move 4 times this. So those are how many? Those are about 4 iterations. Now, where is y2? y2 is y1 plus h f of x1 y1. So what is the f of x1 y1? Because that's majorly what we need to compute. And this is going to be sine of 0.02 plus 2 times y1, which is 1.04. And what are we getting? We are going to find that this is going to be y2, which is y1, which is 1.04, plus h, which is 0.02, times sine, okay, of 0.02 plus 2.08. So put your calculator in radians and find sine of 0.02. Then you add there that 2.08, you multiply by 0.02. And my y2, I find according to the calculator I have, is approximately 1.082. Now, let's proceed. And remember here we have calculated for y2, okay, so which is y of x2, and this is the same as y of 0.04. Yes, so let's move. We go to x3, okay, x3 is x2 plus h, so this is going to be 0.04 plus 0.02, giving us 0.06. So meaning we are going to be looking for y3, which is the same as y of 0.06. So y3 will be y1 plus h f of, y2, which will now be y2 plus h times f of x2 y2. And what is our value of f of x2, y2? So f of x2, y2 is the same as sine of what is x2? X2, we say the sine of 0.04, okay? Then plus 2 times y2. So y2 is already calculated as, so times 1.082. So f of x2, y2 will be calculated. And then we will be able to find our y3, which will equal to what is y1. Y1, we already said it is 1.082 plus h. What is h? 0.02 times this value, sine of 0.04 plus 2 times 1.082. So we find that our y3 is approximately equal to 1.1261. So finally, we have y4, which is now y3 plus h f of x3 y3. But y4 is the same as y of x4, which is the same as y of 0.08, which is the one we are interested in calculating. So what is f of x3, y3? Is the same as sine of 0.06, because we said x3 is 0.06. It is up here. Then plus 2 times 1.1261. Yes. And what is going to be y of 0.08? This is going to be y3, which is already calculated as 1.1261 plus h, which is 0.02 times now sine of 0.06 plus 2 times 1.1261. So what is y of 0.08? This is the same as having 1.1723. So if we want to take this to 3 decimal places, then y of 0.08 will therefore equal to 1.172, 3 decimal places. So this is how we can go through these iterations to determine the solution of the ordinary differential equation at x equal to 0.08 using Euler's method.